All right, here we go. This is going to be Proposition 17. And Proposition 17 says any two angles on a triangle are less than two right angles. So if we wanted kind of a visual aid of this, if we have two right angles, so there's one right angle, and there is a second right angle. That's not a triangle. And we're going to go ahead and try to prove that. So our goal is to show that these angles are all less than two of those angles added together are less than two right angles. So what I'm going to do on this is I'm going to use some shorthand. I'm going to call this angle 1, angle 2, angle 3, 4, and 5. All right, because more times than not, I get my letters confused. All right, so first things first, let's just let triangle ABC exist. Let triangle ABC exist. Also, we're going to let points D and points E, that is going to be on line AC. Okay, we're going to draw them in such a way that we have D star A, star C, star E. So essentially D and E are on the outside of segment AC, or if you want to think about it, A is between D and C, and C is between A and E. Okay, so either we have DA, C, and E. So what we want to do is we want to show that no matter what combination of angles on the inside of the triangle we have, they will always add up to be less than two right angles. So what we're going to do is we are going to reference Proposition 13. So Proposition 13, let's just kind of make a side note here. So Prop 13. All right, Proposition 13 said if we have a straight line, right, and we take another straight line and we intersect them. Proposition 13 says that those two angles, so we'll call this angle A, use a capital letter, angle A and angle B. What it says is angle A and angle B, if you add those two together, they will be equivalent to two right angles. So that's what Proposition 13 says. And it says it doesn't really matter where you draw these two lines. Maybe you draw them right here. And we have a big angle A and a small angle B. It doesn't matter. Those will still be equivalent to two right angles. We're going to use that property here. So just to start things off, let's go ahead and get rid of this. To start things off, we know, and this is where my shorthand comes in, we know angle 1 and angle 2, we'll say plus, we'll use plus sign. Angle 1 plus angle 2. Angle 1 plus angle 2 is equivalent I think I spelled that right. Angle 1 plus angle 2 is equivalent to two 90-degree angles. I'm sorry, I can't use 90, two right angles, to two right angles. Okay, so angle 1 and angle 2 are equivalent to two right angles. Now, the next piece of information that we're going to need to reference is Proposition 16. And Proposition 16 says any exterior angle will always be greater than the opposite interior angles. So what that means is, so by Proposition 16, we know angle 1 is greater than angle 2, and angle 1 is greater than angle 4. Let me try that again. We know angle 1 is greater than angle 3. There we go, because angle 3 and 4 are the opposite angles. So Proposition 16 says angle 1, that exterior angle is greater than the opposite interior angles, being angle 3 and angle 4. And that is going to be useful. So what we have is, what we can say is angle 1 plus angle 2, the sum of those two angles that are equivalent to two right angles, we know that this has to be greater than angle 2 plus angle 3. Okay, and why do we know that? We know that because angle 1 has to be greater than angle 3. right? Therefore, angle 2 and angle 3, angle 2 plus angle 3 is less than our two right angles. All right. Now what we can do is make a similar argument, the exact same thing. We know that angle 1 plus angle 2, again, those two angles that are equivalent to two right angles, that also needs to be greater than angle 2 plus angle 4. Okay, so angle 2 plus angle 4 similarly is less than two right angles. Okay, now the last one we need to show is we showed angle 2 plus angle 3. We showed angle 2 plus angle 4. The last one we need to show is angle 3 and angle 4. Okay, and this is where point E comes into play. So if we look at angle BCE I renamed as angle 5. Angle BCE is supplementary to angle BCA, which I renamed angle 4. Okay, so we know that angle 4 plus angle 5, angle 4 plus angle 5, that's also equivalent to two right angles. Now, using the same reasoning as before, by proposition 16, we know that angle 5 is greater than angle 3, and angle 5 is greater than angle 2. And why do we know that? Because angle 5 is an exterior angle. Angles 3 and angle 2 are the opposite interior angles. So what we can do is we can swap out what we need here. So we know angle 4 plus angle 5, that must be greater than angle 4 plus angle 3. Okay, so we have, so angle 4 plus angle 3 is also less than two right angles. Which is what we were trying to show. Okay, so if we wanted to just clarify things, throw some numbers, add some numbers into this, we just showed that angle 2 plus angle 3 is less than, we're going to say 180. All right, we know that angle 2 plus angle 4 has to be less than our 180, and angle 3 plus angle 4 is also less than our 180. And remember, 180, I'm going to swap that out because I know we have to be a little strict on these things. So this is just less than, or this is, I'm going to say, is two right angles. Two right angles. Okay, and there we have it. So no matter which two angles you pick in a triangle, their sum has to be less than two right angles.